Hi everyone, so this is our very last chapter, and this is chapter 25 on organic chemistry. Now, organic chemistry is on compounds that contain carbon, okay? I know when we hear the term organic, we think of, of foods that are naturally grown without hormones or pesticides and things like that. In the chemistry world, when we say an organic compound, we're just basically saying that it contains carbon. Here are some of your properties of organic compounds, okay? So they do contain covalent bonds, right? If you remember that covalent bonds are produced when you have two nonmetals sharing electrons to make their bonds. And when they share their electrons, that means that those bonds are relatively weak. That's why they have low melting points and also low boiling points. Your organic compounds can also react with oxygen in the air to produce these combustion reactions that we have talked about before, how we had mentioned it's a hydrocarbon plus oxygen and it gives you CO2 and water. And they are usually nonpolar molecules, so then therefore they will be soluble in nonpolar solvents, if you remember the concept, like dissolves like. And these organic compounds can form these really long carbon chains and make these really large molecules. For this entire chapter on organic chemistry, we are just going to focus on naming and writing chemical formulas and drawing their structures for alkanes, alkenes, and alkynes. Now, organic chemistry is very, very vast, and it can contain different functional groups and the reactions in order to make these compounds, but that is something that you will learn in college. All right, so for this chapter, we're just focusing on how to name and draw structures for alkanes, alkenes, and alkynes. In this particular lesson, we are just going to focus on alkanes first, okay? All right, so alkanes contain only carbon and hydrogen, okay? And alkanes also will contain a single bond, and a single bond that is between carbon atoms, and these are what we call saturated compounds, okay? They're saturated. So single and saturated both begin with the letter S. So that is one way that you can remember it. Now, if you recall, carbon is in group 4. So since carbon is in group 4, that means it can make 4 bonds. Okay, remember, each line represents 2 electrons in order to make a bond. All right, so every carbon atom that you draw will have 4 bonds coming from it. Okay, and these are going to be also nonpolar molecules. Now your alkanes, which are the simplest type of organic compound with all single bonds, your alkanes will react with oxygen to produce CO2 and water. So if you remember, these are your combustion reactions. Now your alkane is the same thing as the hydrocarbon that I was referring to at the beginning of the school year, okay? So remember, hydrocarbon is anything that contains carbon and hydrogen. So if you recall, I wrote it like this, okay? It could be any quantity of carbons with a certain number of hydrogens, okay? So an alkane is the same thing as a hydrocarbon. So let's take a look at this table. This table contains 10 of the alkanes. Notice when we name the alkanes, the ending ends in ane, just like alkane, right? Ends in ane. Okay, so notice all the endings end in ane. Now I do want you to notice all of the prefixes here. Okay, all of these prefixes tell you the number of carbon atoms that are in the structure. And these 10 prefixes you will need to have memorized. Okay? Meth, eth, prop, bute, penta, hexa, hepta, octa, nona, deca. All right? So the prefix will tell you, once again, the number of carbon atoms in the structure. And I'll write them down on the next slide. But let's take a look here. Notice what happens to the melting point. So let's look at the melting point and the boiling point okay, as you add on carbons, which means that you're increasing the size of the molecule. So you're adding on more carbons, therefore more hydrogens are also being attached. Notice what happens to the melting and the boiling point. Do you see a trend? Okay, so the melting point is getting higher, and the boiling point is also getting higher. So the melting and the boiling points are increasing as the molecule gets larger. Okay, and that makes sense because now that it's larger in size, there are more bonds to break. Okay, and that means that the bonds are a little bit stronger. It takes more energy to break those bonds. All right, so now let's write down all of those prefixes that you need to have memorized. Okay, so let's see, let's do a chart. Number of carbons. And then let's do prefix here, prefix. Okay, so let's just number 1 through 10. Running out of room. 9, 10. Okay, so now let's write down what the prefix is. So 1 is meth. 2 is eth. 3 is prop. 4 is bute, pronounced bute, but it looks like but. 5 is pent, or you could do penta. 6, hex, or you could do hexa. 7 is hept, or you could say hepta. 8 is octa, or you could just say oct. 9 is nona, or non. Oh, rewrite that. And then the 10, the last one, is deca, like decade. Okay, so all of those 10 prefixes will need to be memorized for your test. Okay, so now what we are going to talk about, we're going to talk about these things called alkyl groups. Okay, alkyl groups. So notice that the ending is YL. So notice here, the ending changes to YL. So basically an alkyl group is a branch, okay? It's a branch that comes off of the carbon chain. So if the alkyl group only has one carbon, it's called a methyl group because meth means how many carbons? 1, right? Now if the alkyl group has 2 carbons on it, see 1, 2, has 2 carbons in it, then therefore it's called an ethyl group because eth means 2 carbons. So this is what it looks like when it is on a carbon chain. So a carbon chain has a whole bunch of carbons, okay, in a line, and then you can see that there are some branches that are coming off of the chain. Okay, and all of these branches in this example only contain 1 carbon in them, so therefore these are called methyl groups. Okay, methyl groups. And once again, this is just an example so you can see what it looks like when there is a branch coming off of the carbon chain. All right, so now what we are going to do is we are going to learn how to name an alkane. So there are all these rules that I'm going to go over, and all of the rules will be the same rules for the alkenes and the alkynes that we will learn about later. Okay, so the first thing that we need to do is you have to find the longest carbon chain. So you have to look at all of the possibilities for the longest chain. For an example, you can count straight across 1, 2, 3, 4, 5, 6. Okay, that could be 1 carbon chain. You can also go like this and count that carbon chain. That would be 1, 2, 3, 4. That would only be 4 though. We can also go this way. So then that would be 1, 2, 3, 4, 5. Okay? So our options are we had a 4, we had a 5, and we had a 6. So 6 is the longest carbon chain. So that's why we will count it straight across like that. Okay, so that's the first rule. You have to find the longest carbon chain. The second rule is you have to count the chain in the direction where the branches will come off the lowest numbered carbon. Okay, so then once again, you will count the carbon chain in the direction where the branch will come off of the lowest numbered carbons. Okay, so then you can count it this way in this direction, which means it would be 1, 2, 3, 4, 5, 6, like that, or you can number it the way it's written on the notes, right? So I know on your notes this is written much better in this program. It kind of shifted things a little, so it looks a little off. So then this branch is really coming off of right here, like that. Okay, or it can be on 1, 2, 3, 4, 5, 6. So you want to look at all the possibilities that you can count the carbon chain. All right, so once again, if we count it in this direction, notice that the branch is coming off of number 4. But if we count it in this direction, the branch is coming off of number 3. So that's why it is correct to count the carbon chain in that direction. So when we name that compound, it becomes 3-methyl hexane. Okay, so the hexane comes from the longest carbon chain, which contains 6 carbons. So the prefix for 6 is hex. And then it ends in ane because it contains all single bonds between the carbon atoms. Okay, so this is like the main part of the chain gets named at the end. All right, then the branch gets named in front of that. And the number here tells you where the branch is coming off of. So this is saying off of carbon number 3 is a methyl group. So remember, meth means how many carbons? 1, right? Because the branch, which was right there, only contains 1 carbon. So that's called a methyl group. So once again, then the name for this compound would be 3-methyl hexane. So here's a summary of the rules on how to name your alkanes. All right, so let's go ahead and do some more examples. Okay, so in these examples, I want you to name them. All right, I want you to name them. So you should look on your paper because they're drawn more accurately on your PowerPoint notes. So I want you to name them. Don't forget, go through the rules. You need to find the longest chain, count it in the direction where the branches will come off the lowest possible number. Okay, so let's go ahead and do A together. All right, A together. First thing we need to do is find the longest carbon chain. So we can first count straight across 1, 2, 3, 4, 5. Okay, that will give us 5. Now let's look at all the other possibilities. So you know it could be a chain if you kind of run your finger across and your finger doesn't lift up. So we can go this way, 1, 2, 3. So that's only 3. We can go this way, 1, 2, 3, 4, 5. That will also give us 5. Or we can go 1, 2, 3, 4, 5. That will also give us 5. So you can look at all those different possibilities. So even this one could go 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, and this one looks pretty symmetrical. So 5 is the longest carbon chain. So then let's just count it straight across because that also gave us 5. So we have 2 possibilities. Well, okay, so let's go ahead and write that down. We already know it's 5 carbons, right, is the longest chain. So at the end, it's going to be pentane, because pent means 5. All right, now let's figure out which way to count it. We can go this way, 2, 3, 4, 5. So that means the branch would come off of number 2 and number 4. Or we can count it in the other direction. 1, 2, 3, 4, 5. Notice here the branches are still coming off of 2 and 4, okay, because this one is symmetrical. So since there are 2 branches, we actually will write the number we write down both numbers separated by a comma. So it looks like this, 2, 4. Okay, then put a dash. Now both of the branches here are methyl groups because they contain how many carbons? They only contain 1 carbon each, right? So we use meth, the prefix meth, because it contains 1 carbon, right? There's 1 carbon there, and then that one has 1 carbon. But they are 2 branches. So then we're going to use a prefix to indicate that there are 2 of these methyl groups. So it gets the prefix di. So these are dimethyl. All right, so then the compound name is 2,4-dimethyl pentane. Okay, 2,4-dimethyl pentane. All right, so go ahead and try part B by yourself, find the longest chain, and so on. So let's look at all the different possibilities for the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. Okay, one of them has 7. We can also go in this direction and all the other directions. We can also go this way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, right? 1, 2, 3, 4. So it seems like 7 is the longest one. 1, 2, 3, 4, 5, 6, 7. Okay, so what's the prefix for 7? Prefix for 7 is hept. So this would be heptane at the end. All right, now let's figure out which direction to count the carbon chain. We can go this way. 1, 2, 3, 4, 5, 6, 7, where the branches will come off of here, which is number 3, and then we would have 2 branches here off of number 5. Okay, so that's one option. Or we can go in the other way. 1, 2, 3, 4, 5, 6, 7. Okay, so if we count in that direction, then 2 of the branches come off of 3, and then only 1 branch comes off of 5. Okay, so we want the lowest possible numbers for all of the branches. So it would be more correct to count it in this direction here. That way both or 2 of the branches are coming off of 3 rather than 2 of the branches coming off of 5. Okay, so since there are 2 of them coming off of 3, you list the 3 twice. So it ends up being 3, 3, and then we have another one off of 5, so 5, and all of these are methyl groups because they only contain 1 carbon. So it'd be 3, 3, 5, and since there are 3 methyl groups, we use the prefix tri. Tri, and then I'm going to run out of room, but write methyl, trimethyl. Okay, so 3, 3, 5, trimethyl heptane. Now we are going to draw structures. I think it's a lot easier to draw structures than it is to name them. And for these examples, they want you to do what is called a condensed structure for them. So let's do part A together. All right, so what I usually do is look at the chain first so we know how many carbons to make. So heptane. So hept means how many carbons? 7. So let's draw 7 carbons. 1, 2, 3, 4, 5, 6, 7. Okay? Remember that each carbon needs to have 4 bonds coming off of it. So we're just drawing out all of the other bonds. Okay? So typically all of these bonds are going to have hydrogens attached to them. Then it's telling us off of carbon 3 and 4, right, there's going to be a methyl group. So it doesn't matter which way you count it, you get to decide, okay? It's up to the person who is naming it to figure out which way you counted it, okay? So then let's just go in this order. 1, 2, 3, 4, 5, 6, 7. Okay, so off of carbon 3, we have a methyl group, which is a CH3 group. And then also off of carbon 4. Now it doesn't matter if you put them side by side like this, or if you have one on top and one on bottom, it doesn't matter, okay? So you could have drawn this other methyl group over here on top, it doesn't matter, okay? Just as long as you put them off of carbon 3 and off of carbon 4. Then everything else here is going to have a hydrogen attached to it. Okay, these are all my hydrogens. So you can draw out the hydrogens if you like. I usually don't, just because I already know that they are hydrogens. Okay, but when you draw these out, you know that these are all hydrogens. This is called the structural formula, where you see all the bonds drawn out. So this is the structural formula. But this particular example wants us to condense it. All right, so when we condense this, just take one group at a time, each little carbon thing. So then this carbon has a CH3 on it, so it'd be CH3. And this one has a CH2. Then the next one is a CH with the branch coming off of it. Then this one also has a CH. Just to make it easier to read, I'm just going to put that one on top. And then this is a CH2. And we keep going. This is CH2. And then keep going. Last part, CH3. Let me just move it across. Okay, CH3 there. So then that is called the condensed structure. So then I want you to do the last example by yourself. Let's move this over. Okay. All right, so then we see octane. So oct means how many carbons? Well, 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. And let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is correct. Then we know that carbon likes to make 4 bonds, so we make sure that all these carbons have 4 bonds coming off of them. Okay, then off of carbon 2, well, there's going to be 2 branches coming off of 2, and they are going to be methyl groups. Okay, so then we could put a methyl group here, and we could put a methyl group there. You could have placed those methyl groups over here on this side if you wanted to count it in that direction instead, and both ways would be correct. Okay, and then all the rest of these are just going to be H's. So you can write the H's in, and then you can condense it. So once again, I like to draw it out like this in the structural formula so I can definitely see how many bonds, make sure I put in the right number of H's and all the bonds in correctly. All right, so now let's condense it. So this is a CH3 group. Then I have only this carbon, right? But then I have the 2 branches coming off of it. So then C. Okay, this is getting kind of messy. Let's raise this up a little. All right, I'm just going to rewrite this part because I'm going to run out of room here. All right, so let's just cross this out here. Okay, I'm just going to write it down here. So CH3, and then I have a C, the CH3, and another CH3 attached to it. Okay, then this is a CH group. Oops. Undo that. Okay, then a CH2 group, sorry. And then another CH2. Then another CH2. And another CH2. And another CH2. Then finally, at the end, a CH3. Okay, so that would be your condensed structure for 2,2-dimethyl octane. All right, so that is everything that I want you guys to focus on for today is how to name and how to draw the structures for alkanes. And it is important that you learn the rules because the rules are the same when we start to learn about alkenes and alkynes. All right? Okay, so that is everything, and I will see you later. Bye.